Good morning, dear students. How are you? I hope all of you are good. Okay, so now uh, I told that in the last class we discussed about circles chapter, and also we discussed about one theorem, and also we done one exercise. We completed one exercise. Okay, so now I told that in the last class we are going to study one of the important theorem as an examination point of view. So what is the theorem? That is second theorem. So that is the length of a tangent drawn from an external point are equal. The length of a tangent drawn from external point are equal. How to prove this? What is this? We'll see now. Okay, this is the statement of the theorem. We know that I told you that to prove the theorem we need to follow these 5 steps. First one is diagram. We need to draw the diagram. Then after diagram, from the diagram we need to write the given. So and also we need to write next step is to prove what we need to prove. So and if any construction is there, we need to do the construction, then we go for the proof. So these are the 5 steps we need to follow to prove the theorem. Okay, so now here they give that the length of a tangents drawn from an external point to a circle are equal. The length of a tangents drawn from an external point to a circle are equal. Okay, for this we need to draw the diagram first. Okay, so we need to draw the diagram first for this. So first we draw the circle of some radius. Okay, for this radius I'll draw one circle, this as a center. Okay, now take the circle shape. Okay, so now the length of a tangent drawn from an external point. So if we take, this is a external point, this is a external point here. Suppose if we draw a tangent from this external point, so do one thing, call this point as A, call this point as B. Okay, so this is the external point. Okay, this is the external point. So now do one thing, so take this line and extend this. Okay, now if we draw a tangent from the, okay, in the last class we discussed that how many tangents we can draw from an external point. I think you remember that case 1, case 2, case 3 we wrote in the classwork, right? Just turn the pages and see how many uh, tangents we can draw from the external point, out from the outside the point. So inside the point we not able to draw any tangent. On the circle we can draw one tangent, but from the external point we can draw two tangents. Okay, we can draw two tangents from the external point. Okay, so now you can draw this tangents. This is a one tangent, and here is a one tangent. Okay, so you can take this as, this is P and this is Q. This is P and this is Q. Okay, now what we need to, okay, I hope all of you understood this diagram. Okay, so now what we need to do, so what we should do now, we need to prove that the length of the tangents, we need to prove that PA is equals to BP is equals to BQ. We need to prove BP is equals to BQ. So before that we need to write the, so diagram we did. So after that given, so given we need to write now. So what is the given? So just look into the diagram and guess what is the given. So we can write that A is the center of the circle. So A is the center of circle. A is center of circle. Okay. Then what we need to do and what they given. So B is the external point, isn't? A is center of circle. B is external point. B is external point. Okay. B is external point. So then what they give? So BP and BQ are tangents. Okay. What we need to prove now? We need to prove that BP is equals to BQ. Okay. So then what and anything is there to do construction? Construction part. Okay, we'll do one thing. So we'll join this AP and also I'll take the shape. Join that AP and AQ. If we join this, okay, what you're going to get? So this is 90 degree, and here this is also 90 degree. Okay, so why? Because from the first theorem we learned that what we learned when we draw a line perpendicular when we draw a line from radius to the point of contact of tangent, then that line is perpendicular. So because of that I wrote this perpendicular, that is 90 degree. I hope all of you understood. Okay, so now what we did, join AP, AQ and AB, we did that. So join AP, AQ. Okay, so and also AB also we joined. Finish. This is given. So write this given as it is. First of all, the diagram is very important. Why? Because suppose instead of A, if you take here O, then here also you need to change O, or else it become wrong. And here also you need to change that one. So do one thing, completely by heart this, by heart or practice, whatever it may be. So as it is, you copy this in the classwork, and also as it is, you copy this in your mind. Or else if you want to try another method, you can try. At least in the sense, you need to practice, you need to at least by heart or do something. Why? Because this question is, as a examination point of view, very important. From all 4 years this question is repeating, so you can expect this question in the final examination for 3 marks, around 80%, 90%, 95% we can give guarantee for this question. Why? Because this is very important theorem. In this chapter we have only 2 theorems. In that theorem, this theorem is very important, and even first theorem also important. This is very important. Sometimes they'll give the option, sometimes what they'll do, they'll give only the first theorem or second theorem, but 90% we can expect this question as a examination point of view. Okay, so now okay, we wrote the given. So next, what is the next step? So to prove. So what we need to prove? To prove what? Tell me. You can't tell, right? To prove, that is a BP is equals to, sorry, BP is equals to BQ. This we need to prove. Okay, to prove we wrote. So then what is next? So next is proof. Next step will go for proof. The construction already we did that, we joined here only, so it's no, we not did any much more constructions. Why? Because the joining is compulsory. Why? Because in the radius we know that is radius. Construction in the sense we need to do some external thing, extra we need to do, that is construction. Here not we not did any extra thing, we joined it. Okay, that is not come under construction. Why? Because the joining of AP is radius, we know already. So next, proof. In this, do one thing, make 2 statements, make 2 boxes, one is statement and one is reason. So now do this. Now we'll write the what is it? Now we'll write this statements and reason for this. Okay. So for a diagram you need to write only once. So only for the reference of this, I'll drawing here also. Okay. So by looking into the diagram, we need to solve this. So first line is your statement. Here statement, and here for what statement you'll give, for that you need to give the valid reasons. Okay. So keep in mind that we need to prove that AB what is that BP is equals to BQ. Okay. So now here you may see that in this diagram we have two triangles. One is APB, another is AQB, isn't? So therefore first statement you write like this. So what is that? In triangle APB and triangle AQB. What we need to do? We need to prove this two triangles are congruent. If two triangles are congruent, then their corresponding sides are equal, isn't? So then we can tell that AP is equals to BP, BP is equals to BQ. So in this first you can write that AP is equals to AQ. We can write these two are equal. Yes, why? Because first statement AP is equals to AQ. Can you tell me the reason why both are equal? Yes, it is nothing but radii of the same circle. These both are radii of same circle. It is radii of same circle. Okay, finish. So second statement. So here you can write here AB is equals to AB. AB is equals to AB. Why? The reason is it is a common side. Common side for the two triangles. So why? Because in the triangle what is it? APB also AB is there, and AQB also AB is there. So therefore this is the reason. So next third statement. Okay, third statement we can write that angle APB is equals to angle AQB, which is equals to 90 degree. Why? Because so this angle also 90, this angle also 90. If these two angles are 90, why it is 90? Because the radius drawn at the point of contact is perpendicular to the tangent. This is the reason you need to write this. So radius drawn at the point of contact is perpendicular. So perpendicular to the tangent. Okay, this is the statement. So therefore, so we can write that triangle therefore triangle APB is congruent to triangle AQB. How it is congruent? From RHS theorem. So RHS, so right hand side theorem. Okay, in the last year you learnt about this and all SSS postulate, RHS postulate. So that is not theorem, that is RHS postulates. Okay, RHS postulates. Okay, then from this we can write that BP is equals to BP is equals to BQ. BP is equals to BQ. BP is equals to BQ. How? From CPCT. What is CPCT? Corresponding parts of congruent triangles are equal. CPCT, corresponding parts of congruent triangle are equal. CPCTE you can write. So hence it is proved. Hence proved. Is it clear? So that we need to prove. Hence we proved. I hope all of you understood this. Okay, I'll repeat this once again. Okay, just look into this. So as a examination point of view, it's very important for 3 marks. So here the question is, the length of a tangent drawn from an external point to a circle are equal. So here this is an external point. So from this, if we draw a tangent, the two tangents are equal. That we need to prove logically. Okay, how to prove it? So first, so all the theorem, not only this theorem, if we take any of the theorem, we need to follow these steps, these 5 steps. First, you need to draw the diagram. So then given, then to prove, then construction, then proof. Like this, the step by step we need to go. Okay, why? Because for each and every step we'll get the marks. Okay, now suppose if we do everything in, if we fail to write this diagram, if we forgot to write this diagram, so they'll get 0 marks. Suppose if you draw the diagram, you'll get only half mark. Suppose if you not write the diagram, you'll get 0 marks. If you do everything same as it is, however in the textbook the same thing you printed, the examination answer paper, then also you'll get 0 marks. Why? Because if you forgot to write the diagram. So for that all the theorems, the diagram is very important. If you not write the diagram, you will not get any marks. Okay. So what is this here? In this okay, in the what is the given, so according to the statement of the theorem, we need to draw the diagram and also given. So here B is the external point, so BP and BQ are the tangents. Okay, so A is the center of the circle, B is the external point, so BP and BQ are tangents. So therefore AP, AQ and AB are joined. We joined that AP. Okay, so next is to prove. What we need to prove? We need to prove that BP is equals to BQ. BP and BQ are equal. That we need to prove. Okay. So then proof in that statement. So in the proof we need to make 2 columns. One is statement and one is reason. So diagram don't need to write again. Once if we write, it's enough. So we're not able to see the diagram there, which is above. So I have pasted here. So a statement, reason. So here we have 2 triangles. This is one triangle and this is one triangle. So the proving congruency is easy for us. Why? Because in the 9th grade and the 8th grade we studied this, how to prove the congruent triangles and how to prove 2 triangles are congruent. So just you can use the same procedure, you can find the congruence. In triangle APB and triangle BAQB, we know that first one AP is equals to AQ. Why? Because this is the radii of the same circle. This is the first reason, and this is the second reason, and this is the third reason. So that is AP is equal, what is that? AP is equal to AQ because the radii of the same circle. And next one, AB is equal to AB is a common side. AB is equal to AB is a common side for the triangles. And in this triangle, this angle and this angle which measures 90 degree. Why? Because the radius drawn at the point of contact is perpendicular to the tangent. It is perpendicular to the tangent. So therefore triangle APB is congruent to triangle AQB according to RHS postulates, right hand side postulates. So therefore if 2 triangles are congruent, then their corresponding sides are equal. So therefore BP is equals to BQ according to corresponding parts of congruent triangles. I hope all of you understood this. Okay, so copy this theorem neatly in your classwork, and after this write this theorem 3 times in the homework book. So write in the homework 3 times. So practice this theorem in the homework 3 times. 3 times you need to practice in the homework. Okay. So and one time you write in the classwork, 3 times you need to practice in the homework book. Okay, I hope all of you understood. So then we'll go for the problems and the remaining things in the next class. Okay, then have a nice day. Take care. Bye.